Good morning. Now, today I would like to talk about the chemical calculations. So today's lecture will be composed of these uh, units we use to calculate the or express different type of chemical calculations, calculation of percent composition, and molecular and empirical formula. Very simple thing, but we try to make it easy if you can understand more easily. So this is our today's topic. Now, if we consider that now what is the units we use for chemical calculation? Now, can you remember what type of unit we usually use? So it is basically, first of all, in your mind it comes that molarity, because molarity is well known and used for by almost all of the corner by the chemist, that molarity. Now, okay, if you think it is molar, so molarity, first our term is molarity. Now, what is molarity? Molarity is basically the unit where we prepare the moles per unit volume of the solvent, and that means moles of any solute dissolved in per volume of solvent. Okay, so I think we all know the solute and solvent. Solute, which is dissolved the solid substance, and solvent, the liquid, which basically dissolve the solute. Now, if we make it more concise, then molarity basically just the moles per unit volume. And in definition, we said that number of moles dissolved per liter solvent. That means number of moles dissolved per 1 liter solvent. Okay, which implies that if I said 1 molar sodium hydroxide solution, now we know that the weight of sodium hydroxide is 23 plus 16 plus 1 equal to 40. So if 40 gram sodium hydroxide, this 40 gram sodium hydroxide dissolved in 1 liter solvent or 1 liter water, then we can say that these two part makes 1 molar sodium hydroxide. Okay, so which implies if 1 mole of solute dissolve in 1 liter solvent, then it is 1 molar. If 2 mole of solute dissolve in 1 liter solvent, 2 molar. If 3 mole, then 3 molar. If half mole, then half molar. So this is the molarity we basically calculate always. And then the another uh, calculation system we can go from molarity, then it is basically the molality. For molality, now the next one is molality. So I just changes with L, molality. Okay, molality. So it was molarity and then molality. So for molality, moles of any solute dissolved in per unit volume, so it will be converted to per unit mass. So which implies we just exchange, if we exchange mass with the volume, then we obtain molality. So in molarity we use volume of the solvent, but in molality we are using mass of the solvent. Now if we are able to use mass, then we will write there 1 kg solvent and we said here mass, so it will be molality. Okay, so basically almost the same, but difference is that one, in molality we use per unit mass, and the molarity we use volume, per unit volume. Now why we need the molarity then? What is the difference? So we know if we go to physics, then there is a relationship between the molar volume and the mass. Now if you look at here, then what will happen if I want to prepare one molal, not molar, if I want to prepare one molal sodium hydroxide, then just I need to dissolve 40 gram of sodium hydroxide in not 1 liter solvent, in 1 kg solvent. Okay, this is the difference between molarity and molality. Okay, now what is the advantage of molality or molarity? Now you see, one we use volume of the solvent, in another one we use mass. So in molarity we use volume, in molality we use mass. Now what is the difference between volume and mass? Now we know that volume equal to, so density equal to mass by volume. So this is the difference between these two. That means if we multiply molarity by the solvent density, then we can get the molarity. And another advantage we have, which is the advantage, now if we consider we are heating the solution, the temperature is increasing, then what will happen? The volume of the solution should be changed, but the mass of the solution remain unchanged. So which implies that if we heat any molar solution at different temperature, its molarity will be different. Like for some instance, it's 1 molar solution, I heat it for like 30 degree, then it becomes 0.8 molar solution. In 40 degree it becomes 0.7 molar solution, just for example. Okay, but for mass I stirred a molal 1 molal solution and I'm heating it. If it is closed vessel, then there will be no change of the mass, it will remain same. So there is no effect of temperature on molality, but there is effect of temperature on molarity. So this is where the basic difference between these two. And then we have another unit which is known as normality. Okay, so what is normality? Now, in case of normality, we have a different scenario. Different scenario, a little bit different, not too much different. So, different scenario, what is it? If we think it is normality. Now, for normality, so now for molarity and molality, we use the moles per unit volume, moles per unit mass. That means moles remain same. But in case of normality, we use different thing. What is the different thing? We bring a new term which is gram equivalent weight. So what is gram equivalent weight? This is basically just divide your molar mass by number of hydrogen or hydroxyl ion present. So that means if we consider HCl, then this N will be 1. If we consider H2SO4, then this N will be 2. If we consider H3PO4, then this N will be 3. If we consider calcium hydroxide, then this N equal to 2. If we consider sodium hydroxide, then this OH, so N equal to 1. If we consider aluminum hydroxide, then N equal to 3. So this is the gram equivalent weight. That means we need to multiply the molar mass of this thing by the number of hydroxyl or hydrogen ion present here. Suppose if we consider about hydrochloric acid, the molar mass of hydrochloric acid is 36.5 gram. So the gram equivalent weight of hydrochloric acid will be divided by 1. That means if there is 1, then there is no difference between molarity and normality. It is same. So it is 36.5 gram. Now what will be in the case of sulfuric acid? We know the mass of sulfuric acid is 98 gram molar mass. Now if this 98 gram divided by this 2, then this is the gram equivalent weight, which implies the gram equivalent weight of sulfuric acid is basically 49 gram. So this is the molar weight, this is the gram equivalent weight. So that's dividing by the number of hydroxyl or hydrogen ion, we will get the gram equivalent weight. Now again come to the definition of the normality. So in the definition of normality, we said that the gram equivalent weight amount of any substance dissolved per unit volume of solvent. That means again volume, like molarity. So the difference between here is that it is gram equivalent weight, and here is the volume is remain same. So it was molar mass in case of molarity, which is replaced by gram equivalent weight. So if we now try to consider that what is basically the difference, okay, so we will tell it again later. Now look at, if we try to calculate the molarity of any solution, okay, now sometimes you will get some question, okay, sometimes you will get some question that what is the molarity of this solution, okay, what is the molarity of this solution, or like how to you prepare this molar solution, like if anyone said uh, how to prepare 0.1 molar sodium hydroxide solution in 250 ml water, okay. Now for this one we use the our famous equation W equal to S mv by 1000. So where W is the amount you necessary to dissolve in this 250 milliliter water, S is the concentration which we want to prepare, M is the mass of this sodium hydroxide molar mass, and V is the volume, this 250 milliliter, and 1000 is the volume, just a volume fraction. So by putting the values here, if we consider, you can see just this one, okay. So how much? Yes, so it is 0.1 molar into M, sodium hydroxide 40 into 250 divided by 1000. So what is the amount? 0.1 into 40 into 250 divided by 1000, so equal to 1 gram. That means if you dissolve 1 gram of sodium hydroxide to 250 ml water, then you will obtain 0.1 molar 250 ml NaOH solution. Okay, this is easy. Okay, now this is goes your molarity. Now you come to the point that molality is already also the same. Now if we consider to prepare molar solution, okay, mole normal solution. Now, so that means if we want to prepare one normal HCl solution, okay. So we know that to prepare 1 molar, we need to dissolve 1 mole in 1 liter. So 1 mole of hydrochloric acid means 36.5 gram, okay, in 1 liter solvent. Now for 1 normal, we need 1 gram equivalent weight in 1 liter solvent. Now that means as for hydrochloric acid, the gram equivalent weight and the molar weight is same because of this 1 hydrogen. So for this one, it is also 36.5 gram in 1 liter solvent. Okay. Now, if we change this hydrochloric acid with sulfuric acid, then what will happen? Now, for sulfuric acid, 1 molar in 1 liter solvent. So this is will be 98 gram, because for sulfuric acid 2 into 1 plus 32 plus 16 into 4, so all gives you 98. Okay. Now for the gram equivalent weight, we calculate that for sulfuric acid there is 2, so 98 by 2, it will be 49 gram in 1 liter solvent. Okay, so if 49 gram in 1 liter solvent, then this is 1 normal and here is 1 molar. So we cannot say that normality for this sulfuric acid is equal to the molarity. Now, what is the factor to find out the equal molar solution from a normal solution or equal normal solution from a molar solution? If you look at this math, then you will find out the factor, the normality. Basically, in normality, we divide M. In case of normality, we divide the molecular weight by number of ions present. It could be S plus, it could be OS minus. Okay. For molarity, we just use M. Now, what is the factor is different between them? Just M. So that means if we multiply normality with N, then we will find out M. So if we multiply normality with N, then we will find out M. That means if we say 1 normal sulfuric acid, then as sulfuric acid has 2 H plus ion, so we can say, so 1 normal sulfuric acid equivalent to 1 into 2 equal to 2 molar sulfuric, 1 molar sulfuric acid equal to 1 molar sulfuric acid equal to 1 into 2 equal to 2 normal sulfuric acid. Or if we consider about from normality to molarity, if we want to convert normality to molarity, then just we need divide normality by N. So that means 1 normal sulfuric acid equivalent to N by N, that means N by 2. 1 more normal sulfuric acid equal to half molar sulfuric acid, or 1 molar sulfuric acid equal to 2 normal sulfuric acid. Okay. Now, in case of what will happen if we use different thing, that means if we use now we just go another one, H3PO4, of all we can use AlOH3. If we consider this one, then just what will happen? 1 normal equal to 1 by 3 molar, 1 molar equal to 3 normal. That's it. Do you understand? From this one, actually this factor is governing this one. Okay. Done. Now this is basically the normality, molarity and molality. Okay. Now consider that if we consider how to convert another widely used in the general side of the unit of concentration is percent composition. So many people actually using it for the basic thing, like basically in medical science you will find out that 5% iodine, 10% iodine, or this type of thing. Now what is a percent composition? Now percent composition is just the easy thing. So before going to percent composition, I want to tell you another story that I said molar mass. So there is a two different thing, molar mass and formula unit. So when you are in my class, ask me this question. There is a difference between these two. What is the difference? I will explain. Don't forget to ask it. It is really a tricky question to make you confused in different type of exam. Okay. So now percent composition. Now if we go for percent composition, then how percent composition, that means how much in 100 ml, how much in 100 gram, how much in 100. Okay, so it could be four different type. Weight by weight, that means you use solute and solvent, this one. If we use weight of the solute and weight of the solvent, then do the percent composition, then this is weight by weight. If you use weight of the solute and volume of the solvent, then make the percent composition, then this is weight by volume. If we use volume of the solvent and volume of the solute, and the volume of the solvent, then it is volume by volume. If you use weight of the solvent and weight of the solute and the volume of the solvent, then it is weight by volume. Now how you will determine? Now if it is tell that 10% weight by weight sodium hydroxide solution, which implies 10 gram sodium hydroxide dissolved in 100 gram solvent. So 10 gram NaOH in 100 gram solvent. Okay. Now if we consider, if it is said that 10% weight by volume, then just 10 gram sodium hydroxide in 100 ml solvent. If it is said that 10% volume by volume sodium hydroxide, then 10 ml sodium hydroxide in 100 ml solution. If it is said that 10% weight by volume sodium hydroxide, then it is just 10 gram sodium hydroxide in 100 ml solvent. This is very easy. Okay. Now how to convert this volume to molarity. So in case of biological experiment, we face too much problem for that. Okay, because most of the biological students are from biology background. So basically we use a lot of calculation where we use gram by volume, and sometimes for writing the manuscript we need to convert it into molarity. So this is very easy now. Okay, so I will show you only one. Right. Okay, so I'm be concentrate here if you are a biology student. Now like 10% weight by volume sodium hydroxide solution we used. Now what will be the concentration in molarity? It is easy. Okay, man. Now you calculate the 10% weight by volume, that means 10 gram sodium hydroxide in 100 ml solvent. Now if we go for the calculation, as we said, W equal to SMV by 1000. If we go for this one, then okay, So then what we can write for, we need this one, okay? S equal to 1000 W by mv. Now what you have here, W equal to 10 gram, okay, V equal to 100 ml, okay, and M equal to, we all know, for sodium hydroxide is 40 gram, okay. Now we have these three and we have this one. As I said, for according to the linear equation, we have this one, this one, and this one. Now it is easy to find out this one. Now what will be S? 1000 into what is W? 10 gram. 10 gram divided by what is M? 40. What is volume? 100. So what is the result? Just 1000 into 10 divided by 40 divided by 100. So it is just 2.5 molar. So which implies 10% weight by volume sodium hydroxide is equal to 2.5 molar sodium hydroxide solution. So it is easy, okay. Now if you can say, if it is not weight by volume, if it is weight by weight, then what I need to do, just I need to weight, so this will be 100 gram. I need to just multiply this 100 gram by the density of water. Then if we multiply the 100 gram by the density of water, then I will found the, so we know density equal to mass by volume. So I have mass. So now I need the volume. Just volume equal to m by rho. If it is W by W, then I need to divide this W 100 gram by the rho. Now, if it is volume by volume, then I need to do for one, just for the solute, divide the solute volume by rho of the solute. Then we will find out, we can interconvert the weight by volume to molarity, volume by volume to molarity, weight by volume, weight by weight to molarity. Okay, it is easy. And also now we can interconvert the normality to molarity and molarity to normality. So this is the basically very simple thing. Now we will go another calculation, which is called percent composition. Okay, percent composition, it just a similar to the calculating the what is the percentage of the contribution of any element in any compound. Okay, we want to just contribute find out the contributions. Okay, now if we want to find out the contributions, then what will happen, what we need, this is very easy, the simple thing that like percent equal to part by whole into 100. That means if we consider in sulfuric acid, like I want to calculate sulfuric acid percent composition. Now we know that sulfuric acid has 2 into 1 plus 32 plus 16 into 4. Okay, so 2 into 1, that means if I want to calculate the percent of hydrogen in sulfuric acid, then I need the part means 1 hydrogen into how many hydrogen molecule atom is there, 2, divided by whole is 98. So the value of this one is 98 into 100. If I consider about that percent of like sulfuric acid, then it is basically 1 sulfur is 32, only 1, so we can use 1 or not. Okay, by 98 into 100. For percent of oxygen, it is 16, the atomic weight, into 4 divided by 98 into 100. So each case we are using the atomic weight, be careful. Then what will be the percentage of this one? That means for hydrogen, 2 divided by 98 into 100, 2.04%. For sulfur, it is 32 divided by 98 into 100 equal to 32.65%. Then 16 into 4 divided by 100, divided by 98 into 100, 65.3031%. Okay, so this is basically the percent composition, and the most interesting thing of the percent composition calculation is if you add all of this percent composition, you will find out 100, around 100 or 100. Okay, so this is basically simple thing to calculate the percent composition. So what is the step if we consider about another compound, like if it is like potassium permanganate, then we know the molar mass of potassium permanganate is 158. Now the atomic mass of potassium is 39.1, manganese is 54.94, and oxygen is 16. Now at first we have to divide for percent composition of potassium, 39.1 of potassium divided by total weight of potassium permanganate 158 into 100. Then for manganese 54.9 gram divided by 158 into 100, and for oxygen 64.0 divided by 158 into 100. So now if we calculate the composition, just calculation of it, it will give you 24.7% potassium, 34.8% manganese, and 40.5% oxygen. If you add all of them, it will give you 100%. This is the basic concept of percent composition, and it is very easy. Now can we calculate the percent composition of glucose, which is C6H12O6? So C6H12O6 glucose. Okay, now C6 means 12 into 6 plus 1 into 12 plus 16 into 6. So all of them will give you 180. Now start with me. Percent of carbon will be 12 into 6 divided by 180 into 100. Percent of hydrogen will be 12 into 1 divided by 180 into 100, and percent of oxygen will be 12 into 16 into 6 divided by 180 into 100. Then what will be the result? So the result will be, okay, so what is the percent composition if we divide carbon? So it is 40%, hydrogen 6.67%, and oxygen 53.33%. So that means now it is easy for us to calculate any type of percent composition. Now what is the use of this percent composition? There is something to tell you again. So we have two different type of formula. Okay, one is molecular formula, another one is empirical formula. So what is molecular formula? Molecular formula is just the exact amount of atom present in a molecule. Exactly same it will be said to you. So like if we consider about this glucose or any other compound you are seeing here, so the molecular formula gives you exact number, okay, but empirical formula will give you the simplest ratio possible between them. If we consider about like a compound C4H10, so this is the molecular formula. Now what is its empirical formula? The simplest ratio we can write C2H5, or you can consider for glucose C6H12O6. It will be the simplest formula CH2O. So the CH2O is the empirical formula which determines the simplest ratio, and C6H12O6 is the molecular formula which gives you the exact number. Now how to calculate this molecular formula or the uh, empirical formula from a percent composition? If we look at this point, this is the last topic we are talking about today, and also before that I give you some examples for calculation of the percent composition. You can calculate and then make sure that you obtain this result which is shown in the screen, and then you will be smart enough to get and be confident, and you can do this math easily. Okay, now if we consider to find out a molecular formula or empirical formula, now we will use this percent composition what we actually obtained here. Now for this type of equation you have on one question, that if a compound having carbon at this percentage, hydrogen this percentage, and oxygen this percentage, then what is the empirical formula of this compound? Okay, this is one type of question. That means if this is the percent composition of a compound, then what is the empirical formula? Or if this is the percent composition of a compound and its molecular mass is like 180 gram, then what is the molecular formula? So that means two different type of question you can get. One, what is the molecular formula, or what is the empirical formula. Now at first we go for the empirical formula. Now we have this percent composition, that means hydrogen equal to 6.67%, so carbon equal to 40%, and oxygen equal to 53.3%. Now, at first, after obtaining this percent composition, the first and foremost responsibility of yourself to find out whether all of them will give you around 100% or not. Just add them. If it is 100%, then you need not to worry. If it is a organic compound and your result is 95%, then the rest 5% will be, if there is no oxygen, then the rest 5% will be oxygen. If there is no carbon, then the rest 5% will be the carbon. If there is no hydrogen, then last 5% will be the hydrogen. So from this one, we can calculate also if one of the percent composition is not given here. Now we have the percent composition and 100. Now we ready to go. So what you will do, so for the hydrogen, at first we will divide all of the percent by its atomic weight. Okay, so for hydrogen it is 6.67% divided by atomic weight 1. For carbon it is 40 divided by 12, the weight of carbon is 12. For oxygen we will divide 53.3% by 16. Okay, now if we consider that, what will be the result? So this is the ratio of the percent composition and the atomic weight of each atom. Okay, so it will be 6.767, and this one will be, so 40 divided by 12 equal to 3.33 and 53.33 divided by 16, it is also 3.33. Now in the next step we need to divide these ratios by the smallest one. Divide by smallest one. Divide the smallest one. Then 6.67 divided by 3.33. 3.33 divided by 3.33. 3.33 divided by 3.33. Okay, so this is the smallest one. We have two, so we divide anyone, no problem. Now this is a 2.01, this is 1, and this is 1. Okay, so that means we obtain a ratio, so we can write it 2.0, we can write it 2. So the ratio of carbon, hydrogen and oxygen in this compound should be carbon 1, hydrogen 2 and oxygen 1. So it is CH2O. So this is actually the empirical formula. Okay, this is the empirical formula we obtained from this calculation, that CH2O is our empirical formula for this compound calculated from the percent composition. Okay, now in this case, in this step, sometimes you need to multiply, because if I get here 1.5 and here 1, then I cannot use 1.5. You know, the atom cannot be divided. Okay, then I need to multiply by 2 to make it equal number, like 2 into 1, 2. This is 2 and this will be 3. So this is called multiply to make an integer. Okay, so this is the steps. Now if we again tell the step, what is the step? First, divide all the percent composition by its atomic weight, and atomic weight, get the ratio, divide all the ratio, the result, by the smallest ratio you have, and then make it integer. How we will make it integer? If it is 1.5, we can multiply by 2, all of them, then it will, all of them will be the integer. Integer means there will be no point. Okay, so by this one we can get our empirical formula. Now how to get the molecular formula? So what will be the molecular formula of this compound? Now I said that to calculate the molecular formula you need one information. One is you need the molar mass of this compound. So then they will say this is the percent composition and the molar mass of this compound is 180. Then calculate the molecular formula. Or they will say the vapor density of this compound is like 90, because we know that molar mass is equal to 2 into vapor density always. So if there is vapor density or the molar mass, so it is molar mass. Okay, so molar mass always 2 into vapor density. So this is the density and this is the molar mass. Now either they give the density or molar mass, you can calculate. This is the vapor density. So either they give the vapor density or molar mass, you will be able to calculate the formula. Okay, so how you will be able to calculate the formula? Now suppose in this case they give us the molar mass. Okay, so I can delete this one. Now they said the molar mass of this compound is 180 gram. Now we know that the empirical formula is nothing but just a simplest ratio of the molecular formula. So now if we multiply this simplest ratio, this molecular empirical formula, by a integer or the simplest ratio, then we will find out the molecular formula. So this is the molecular formula of this compound. Okay, CH2O is the empirical formula into X equal to molecular formula. Now we can write that. That means CH2O into X equal to the weight of this compound. If it is the molecular formula, then weight of this compound is 180. That means we can write 12 plus 2 into 1 plus 16 into X equal to 180. Now we can write 12 plus 2 plus 16 into X equal to 180. So 30 X equal to 180. So therefore X equal to 180 by 30 equal to 6. So that means the simplest ratio is actually 6. Now if we multiply this CH2O by 6, then you will get the molecular formula. So the molecular formula will be C6H12O6. So which implies that from this calculation we find out the empirical formula of our compound, the given percentage is CH2O, and the molecular formula from this one we calculated C6H12O6, because from the density we calculate the factor which is multiplied by the empirical formula will give the molecular formula is 6. So C6H12O6. This is simple. Now I am giving a lot of example for your practice, and before going there again we try to remind: divide by atomic number, make it simple, and then divide by the smallest one, make it integer, and then for the this is the empirical formula done. For the molecular formula you need to multiply the empirical formula by a factor. This will be equal to the molecular formula. Now I said the vapor density. If it was vapor density, it should be 90 into 2. That's it, nothing else. Everything is same. So 180 or 90 into 2. If it is vapor density, then 90 into 2. If it is 180, then 180 molar mass. From this one we find out 6 and thus multiply the empirical formula by the 6. Then you will obtain the molecular formula. This is the simplest method. Okay. Now you have a lot of work to do. I give 10 different type of calculation here. Go for them and complete them, and then you will find out that you are able to calculate them. And also for the for another problems, like for chemical calculation, solution will be, now one thing is that sometimes we said that, like, find out the number of ions present in 1 molar sodium hydroxide solution. So if you go for calculation, then 1 molar sodium hydroxide solution will give you 1 hydrogen ion and 1 hydroxyl ion, so 2 molar ion. This is simple. And 1 moles means 6.023 into 10 to the power 23. So 2 mole means into 2. So if the number of ion they ask you to find out, then just this one. Okay. And from this calculation we can find out any kind of element having different ions. Like if someone says how many hydrogen ion present in 0.5 molar sulfuric acid solution. Now we know that in 1 mole sulfuric acid or 1 molecule of sulfuric acid, it contains 2 hydrogen ion. So 0.5 molar should be double 1 molar sulfuric hydrogen ion. So the answer will be 1 molar hydrogen ion present in the solution. This is basically the simplest method we can use, and this is the simplest formula. So I try to make it very simple, but and also I can use Bengali sometimes. If you need, please just say to me or inform. সো বাংলায় শুনতে চাইলে বাংলার জন্য বলা যেতে পারে, আমি তখন হয়তো চেষ্টা করব যে বাংলায় সাউন্ডটা দেওয়ার জন্য। And actually basically এখানে so I'm trying to give all the idea here, and when you obtain some video you should not make it copy, because we have some intention that make it copy, and then we are trying to show that we are doing something. So don't be a copycat. Okay, so don't be a copycat, try to make in your own style, because you know every person is different and they have different style. So your style might be better than me, so follow your style, teach student from your style, so it will be very helpful for them, and they will be able to understand your words more clearer than myself, and your technique might be better than me, because you are the human being who have independence to create anything. And so if we follow our own style, so it is better for us to follow ourselves, to follow our own style. And thank you. Have a wonderful day. Hope this video will help you, and keep me in your prayers, and I will keep you too. Thank you. Have a wonderful days.